So today we're going to go over a very useful tool called the chain rule. The chain rule helps us compute larger, more complicated derivatives than we've been able to do by making use of all of our previous rules. So let's start with an example. Let's look at this problem here. We have the derivative of the quotient of 8x squared plus 3 raised to the 10th power. Now, the only way that we know how to do this up until this point is by expanding this. So if we expand it, we get 8x squared plus 3 written out 10 times. And from that, now we have to expand it even further to get the polynomial form, which I have here. After completing that, now I can finally go through and take the power rule of each individual part to get the final derivative down here, which, as you can see, this was typed out instead of handwritten because this would be an incredibly arduous process and not worth my time to go through and do. So is there a better way that we can actually solve this problem without having to expand the whole thing and then do a bunch of power rules? Well, the answer is yes. The answer is with chain rule. Chain rule, which is written out here, is the derivative of f of g of x is equal to f prime of g of x times the derivative of g of x. So let's write this out just a little bit more clearly with some colors just so we can get a better hang of this. So this is asking d dx of, and I'm going to write f of x with blue and then g of x in red. G of x here. Alright. And so then when we take the derivative, we are going to take the derivative of the outside function, which is f here, leave the inside the same, g of x, and then we're going to go through and we're going to multiply by the derivative of the inside. So let's take a look at how this makes our life a little bit easier with our example here. So 8x squared plus 3 to the 10th power. Okay, so let's go through and just start defining what our functions are. So we have on the outside here in blue, we've got this quotient raised to the 10th power. So let's call this f. F of x is equal to whatever's on the inside raised to the 10th power, right? And this stuff that's in the inside is our g of x. G of x is this 8x squared plus 3 polynomial. And if we go back and we look at our rules for derivatives for the chain rule, we need to find the derivative of the outside, keep the inside, and then differentiate that inside and multiply it. So let's write that out again. So d dx of f of g of x is going to equal f prime with the inside function staying the same, and then multiplying that by the derivative of the inside. Okay, so let's find what the derivative of the outside function is, f of x. So df dx, that's going to be just a power rule, right? So if we say that this is x on the inside, which is actually going to be our g of x here, but if we treat it as a power rule, we can bring this down. We get 10, the inside, x, to the 9th power, okay? And let's do the same thing for g. So we get d of g of x is equal to, and now this is just power rule, so this is going to be 16x. 3 is just a constant. And now let's put this all together. So we have our f prime, which is going to be our 10, and then we're going to put the g of x in there. So let's put in what our g of x is, which is this 8x squared plus 3, what we started with. And finish this off with a 9th power. And now we're going to multiply it by the derivative of g of x, which is 16x. 16x. And there we have it. This is the derivative. So d dx is equal to 10 times 8x squared plus 3 to the 9th power times 16x, also known as 160x, 8x squared plus 3 to the 9th power. And that was significantly easier than going through this whole process. So as we can see, chain rule makes things a lot easier to work through. So now I've got about 15 practice problems that we're going to work through. So you can skip ahead to a harder problem or work through each problem with me, but we're just going to go through each step to make sure that we really understand how to use the chain rule. Alright, so in this first problem, we are differentiating 3x minus 2 to the 5th power. So this is very similar to the last one that we just did. So we can go ahead and see that our outside function here is this to the 5th power. So that's going to be our f of x is equal to the 5th power, and then our g of x is going to be the inside, which is 3x minus 2. So let's go ahead and differentiate. So that outside function is going to come down as a power rule, so 5. And now we're going to keep the inside, which is our g of x here. So this is going to be 3x minus 2. And since we're differentiating f of x now as a power rule, this becomes to the 4th power. And now we're going to multiply it by the derivative of g of x, which is just 3. So our final answer is 15 times 3x minus 2 to the 4th power. Not too bad. So now we are on to question 2, where we're getting a little bit more complicated with using our trigonometry. So the way that I like to write this out is I'm going to start by writing everything that we have, and then I'm going to write dx of whatever, just so we can keep track of everything. So let's start this. We've got our outside function, which is sine 4x. And we know that the derivative of sine is going to be cosine. So we get cosine of the inside, which is our 4x. So we're going to keep that there, 4x. And now let's write this dx of the inside, just so we can keep a little bit more track as we get into the harder problems. And now we can solve this once more. So cosine of 4x times 4. And that gives us the answer of 4 cosine 4x. There we go. Not too bad. Now we are on our third problem here. I like to rewrite this square root as a power, just because that makes a little bit more sense and helps me recognize that this is actually a power rule that's going on the outside. So let's rewrite this as y is equal to all of this, 5x squared plus 1 raised to the 1/2 power. Now if we go through, we can do some power rule on the outside function, leave the inside the same, 5x squared plus 1, and then subtract this by 1, we get negative 1/2. And we're going to do dx of the inside, 5x squared plus 1. We get our final answer here being 1/2 5x squared plus 1 to the negative 1/2 times the derivative of this polynomial, which is 10x. So we can go through and write this out as 5x all over the square root of 5x squared plus 1. There we have it. On to our fourth question here. We've got the natural log of 2x plus 3. So remember, with natural log, you're going to do 1 over x. So natural log, let's remind ourselves, of x is equal to 1 over x. So here we've got our inside function being this polynomial again. So our derivative is going to be 1 over the inside, which is this 2x plus 3. And then multiply it by the derivative, ddx of the inside, 2x plus 3. And we get 2 all over 2x plus 3. Question number 5 here, we've got our e function here, and now we need to recognize that we've got e to the x, that's going to be our outside, and then our inside is actually x cubed. So remember, the derivative d dx of e to the x is just e to the x itself. So when we differentiate, we're going to get e, which is actually this derivative e, to the x, which is our inside function, x cubed. And now we multiply the whole thing by the derivative of the inside function, which is x cubed. So we get e to the x cubed times 3x squared. So we can rewrite this as 3x squared e to the x cubed as our final answer. All right, question 6. Now we're getting even more complicated. Up until this point, we've just done one thing of chain rule. Now we're introducing another step of chain rule. And as you could imagine, it's called chain rule because you can keep going. You can go up to 2, 10, 20, 100, 1,000 times. Obviously, you're not going to be asked on a test to compute the 1,000th derivative by chain rule, but just so you know, it can keep going. So let's take a look at this problem. We've got derivative of y equals sine of the quotient 2x minus 1 to the third power. So let's break this apart step by step. We've got the outermost function. I'm just going to rewrite this with colors. So we've got y equals, our outermost function is going to be sine of the inside. Let's use red. And this is actually going to be the cube here. And then inside this cube, even further, let's write in green, is 2x minus 1. So here we've actually got three things going on. We've got the sine, we've got the cube, and we've got the polynomial. So we're going to have to keep chaining this out a few times. So let's take a look what happens. So we're going to start out, right? So y prime is going to be the derivative of the outermost, which is sine here. The derivative of sine is cosine. And then we're going to keep the whole inside. So this whole thing is going to stay the same on the inside. So 2x minus 1 to the cube. Close that off. And now we're going to differentiate d dx, the inside, which is going to be this whole cube thing, the whole thing. So we've got 2x minus 1 cubed. We're going to differentiate that whole thing. So now let's just work on this problem here, right? So this is now just its own problem, 2 steps, 1 chain rule. And then we'll come back and put everything together. So like before, we're just going to go and do the power rule of the outside, which is going to be 3 times the inside, 2x minus 1, to the second power. And now we have to find the derivative of the inside, dx of 2x minus 1. And now we can break this again and find the derivative here, which is just going to be 2. So now if we put everything together, we're going to get cosine of 2x minus 1 cubed times 3 of 2x minus 1 squared times 2. Alright, and now if we put everything together, we're going to get our final answer being 6 2x minus 1 squared times cosine of this whole thing, 2x minus 1 cubed. And that is our final answer. Okay, we've got another problem here. Y is equal to e to the sine of x squared. So we've got a lot going on in this one as well. So let's break it apart. We get y is equal to e, let's write it in blue, e to the sine, let's write that in red, sine of, and then the innermost here is x squared. Okay. So y prime is going to equal the derivative of the outermost, which is just e, So the derivative of e to the x is e to the x. So e to the same stuff, sine of x squared. And we're going to multiply this by the derivative of the inside, which is sine of x squared. Okay, and now let's work through this part. We get the derivative of sine is going to be cosine of the inside, x squared. And then we multiply this by the derivative of the inside, x squared. And we break that apart one more time. We get 2x. Okay, so if we write everything together, we get e to the sine of x squared times cosine x squared times 2x. And we can rewrite this as 2x e to the sine x squared times cosine x squared. And that is our final answer here. Okay, on to our next question here. We've got y equals natural log of cosine of 3x. So let's rewrite this with our colors. Y is equal to natural log is our outermost. We've got cosine as the middle here, and then 3x as our innermost function. So as always, we start by differentiating the outside, which is our natural log, which is going to be 1 all over the inside, which is cosine 3x. And now we're going to multiply that by the derivative, d dx of the inside, cosine 3x. And now if we split this, we can go through and differentiate the inside, which is going to be the outermost function in this case, and this should be in green. Our outermost function is cosine, so the derivative of cosine is, of course, negative sine, don't forget that, of the inside, 3x. And now we take the derivative of the inside function, d dx, the inside, which is 3x. We break this apart again, and we have the derivative of the innermost function is just 3. So we put this all together, we're going to get negative 3 times sine of 3x all over cosine of 3x. Now this isn't the full answer yet, because we actually have what's right here, which is sine of 3x over cosine of 3x, which we can actually simplify even further, and we can get negative 3 tangent of 3x. And that will be our final answer. Alright, so we've got another question here. Y equals 1 plus e to the negative x all to the negative first power. So let's write this out with our colors again. Y is equal to our outermost function, which is going to be this negative 1 power. And then our inside function is this 1 plus e raised to the negative x. And that is all to the negative first power. So we differentiate, we take the derivative of the outermost function first, which is going to be equal to negative 1 times, or of the whole inside, all raised to the negative 2 power. And now we multiply this by the derivative of the inside, which is going to be 1 plus e raised to the negative x. We break this apart, we get the derivative here being, now of course this 1 is going to go away, and we're left with this e, so we get e raised to its same inside, negative x, and then we times it by the derivative of the inside, which is our negative x. We break it apart one more time here, and we get the derivative of negative x is negative 1. So now if we put everything together, we are going to get, So we've got two negatives, a negative and a negative, so that's going to be positive. So we get e to the negative x times 1 plus e to the negative x to the negative second. So we can rewrite that as e to the negative x all over 1 plus e to the negative x squared. We are now on question 10. So the derivative of y equals, and this is all to the fourth power, tangent of 2x squared plus 1. So let's rewrite this with our colors. Y is equal to our outside function is this fourth power. Next is going to be our tangent of, and then inside we've got this polynomial 2x squared plus 1. And this is all raised to the fourth power. So when we take the derivative, y equals derivative of the outside is going to be 4. We keep the inside, tangent of 2x squared plus 1 raised to the third power, because we did power rule here. And now we take the derivative of the inside, tangent of 2x squared plus 1. And we take this break. We know that the derivative of tangent is going to be secant squared of the inside, 2x squared plus 1. And then we multiply it by the derivative of the inside, which is the polynomial, 2x squared plus 1. And we break. We find the derivative of the polynomial, which is just 4x. So if we write this all together, we are going to get 4 tangent 2x squared plus 1 to the third power times secant squared 2x squared plus 1 times 4x. And simplifying it, we're going to get 16x tangent, and this should be a cube, tangent cubed 2x squared plus 1 secant squared 2x squared plus 1. And there we go, full answer. We are on question 11. We've got the derivative of the fourth power of sine of cosine of 2x cubed minus 1. So we've actually got 4 different things going on here. So let's write it out and see what we've got going on for us. We've got y equals sine. I'm actually going to rewrite this as this fourth power being on the outside of sine, because it is going to go over here on the outside, and this is going to be our outermost function, actually, instead of sine. So sine is our next one, which is going to be inside here. Inside of sine, we've got cosine. And even further, we've got this polynomial, 2x cubed minus 1. And let's close all of these things off, make sure we're keeping track. And then, like I said, the fourth power is going on the outside, just so we can really keep track of everything. Alright, so let's start differentiating. We got the power rule on the outside, so we know how to deal with that. 4 times sine of cosine of 2x cubed minus 1. All of the inside staying the same. And power rule, that's going to be 3. Now we're going to take that and differentiate the inside. So that's d dx of this sine of cosine of 2x cubed minus 1. And close everything off. Break it apart. And we get the derivative of sine is going to be cosine. So we get cosine of the inside cosine of the purple polynomial, 2x cubed minus 1. Close it all off. That should be red. And now we're going to differentiate it by the inside cosine, so d dx, the inside cosine of 2x cubed minus 1. And we break again, we get the derivative of cosine is negative sine of the inside, which is 2x cubed minus 1. And we take the derivative of the inside, d dx, 2x cubed minus 1. And we break one last time here, we get the derivative of the polynomial, which is just going to be 6x squared. So now we can write it all together, and we get y prime is equal to this whole thing, 4 times sine of cosine of 2x cubed minus 1 all to the third power times cosine of 2x cubed minus 1 times negative sine of 2x cubed minus 1 times 6x squared. Alright, and let's simplify this as much as possible, and we get y prime is equal to negative 24x squared sine cubed of cosine 2x cubed minus 1 times cosine of cosine 2x cubed minus 1 times sine of 2x cubed minus 1. Alrighty, there we have it. Alright, we are now on question 12. And on this question, and for the future of these questions, I'm going to kind of take a little bit of a shortcut. So in our previous problem, and all of the previous problem, we've kind of been doing it by these steps here, right? Where we go down, we go down, we go down, and then we rewrite everything all together. But that's a lot of writing, and a lot of extra steps, and a lot of extra time. And remember, the whole point about chain rule is that we want to save time, so this extra writing is kind of negating that. Now, of course, if we actually went through and did this problem by hand without chain rule, we don't really see a clear path on how to do that, and it would take significantly longer, especially if we wanted to do this with the limit definition of derivative. So what we're going to do here is, I'm still going to keep everything color-coded, but rather than doing each of these steps, I'm going to go through and I'm just going to chain it out a little bit more just in one line, so we don't have everything all cluttered and taking all this extra time. This will also help on your homeworks, your quizzes, your tests, just to help save that time, because I know you're going to be time crunched to do some of these problems. So let's take a look at this problem. We've got y is equal to e raised to the power of the square root of 1 plus tangent of 3x. So we've got a lot going on here, so we can color again. So we've got y is equal to outside function of e. First inside function is going to be the square root. And then we've got 1 plus tangent, and then inside that we've got 3x. Alright, so let's work through this. We've got y prime is equal to the outside function, which is e. Let's keep it color-coded. E raised to the power of 1 plus tangent of 3x. And this should be taken out a little bit. And now we're going to take the derivative of the inside function, which is this red square root. So I remember that the square root is a power of 1/2. So I'm going to multiply this by the derivative of the inside function, which is going to be 1/2 times the inside, right? 1 plus tangent of 3x. And close that off. And bring this to the negative 1/2. And now we're going to take the derivative of the inside function in green. So remember that the derivative of tangent is going to be secant squared. So secant squared of our inside, 3x. And now the derivative of the inside is 3. So that was a lot faster, just going through and writing it all out. So this is actually going to be our complete answer, and if we want to simplify this a little bit, we will get that y prime is equal to 3 times e to the 1 plus tangent 3x all under square root times secant squared of 3x, and all of this over 2 times 1 plus tangent of 3x under square root. And there we have it. So even faster now. Alright, question 13. We've got y is equal to the natural log of 1 plus e to the x squared. So let's write this out. We've got y is equal to, the outermost function is our first natural log, and then we've got a second natural log. And then we've got in here 1 plus e, and e is raised to the power of x squared. So we can close everything off, and let's differentiate. So y prime is equal to 1 over, remember natural log, 1 over x, so that's going to be our inside, which is natural log 1 plus e to the x squared. And now we're going to multiply this by the derivative of the inside, which is our red natural log. So we get 1 over the inside again. So 1 plus e to the x squared. And now we're going to multiply this by the derivative of the green part, which is just e raised to the x squared. And then the derivative of x squared is 2x. So we get our final answer as 2x e to the x squared all over natural log 1 plus e to the x squared times this quotient of 1 plus e to the x squared. Alright, so we are on to our 14th question here with y is equal to the arctangent of the square root of 1 minus x over 1 plus x. Let's start by reminding ourselves of the derivative of arctangent. So d dx of arctangent is equal to 1 over 1 plus x squared. So if we go and rewrite our problem here with our colors, y equals arctangent of the square root of 1 minus x over 1 plus x, all in arctangent. Okay, so now if we go ahead and start to differentiate, we've got y prime is equal to the derivative of our outermost function, which is arctangent, so that is going to be 1 plus the inside, which is the square root of 1 minus x over 1 plus x, and this is going to all be squared. Now we multiply it by the derivative of our inside, so we've got 1/2 times our quotient on the inside, 1 minus x over 1 plus x, and then this is going to be to the negative 1/2 power, and we differentiate by the inside, which we actually will need to use quotient rule for. So that is going to be doing the bottom 1 plus x times the derivative of the top, which is negative 1, minus the top 1 minus x times the derivative of the bottom, which is just 1, all over the bottom squared, 1 plus x squared. Alright, so this is actually our completed answer, but we can go ahead and simplify this a bit to make it look nicer. So if we rewrite our first fraction, we get 1 over 1 plus 1 minus x over 1 plus x. Our second fraction will be 1 over 2 times the square root of 1 minus x over 1 plus x. And our third fraction here will be negative 2 over 1 plus x squared. If we use common denominators on this 1, we can rewrite this as 1 over 2 over 1 plus x, which we can flip to get 1 plus x over 2. And we multiply by the rest of the fractions here. 2 square root of 1 minus x over 1 plus x times negative 2 over 1 plus x squared. Now we can do some canceling out. We can get rid of a 2 with a 2, and we can get rid of a 1 plus x with a 1 plus x. So we can rewrite our final answer as negative 1 over 2 times 1 plus x times the square root of 1 minus x over 1 plus x. Alright, we have made it to our final problem, question 15. Y is equal to secant cubed of x squared plus 1 to the 4th power. So let's write this out as we do. So y equals, and once again I'm going to bring this 3 to the outside so I know that it is our outermost function here. Our next inside is going to be secant of this inside, which is going to be the 4th power. And then our innermost is the polynomial x squared plus 1. And we'll close this off with a 4th power. And then our outermost is the 3rd power. So let's take the derivative. Y prime is equal to, and let's do our power rule. So 3 secant inside is our x squared plus 1 to the 4th. Close that off and finish our power rule so we get a squared. And now remember, the derivative of secant is secant tangent. So we're actually going to have to write the inside of secant derivative twice. So let's see what that looks like. So the derivative of secant is secant the inside, and let's keep our colors, x squared plus 1 to the 4th, close that off, and we still have our derivative is secant tangent, so we get tangent times our inside again here, x squared plus 1 to the 4th. So we do have the inside written here twice, but remember that this is just how the derivative of secant works. We're not actually going to take the derivative of the inside twice. We're just going to take the derivative of the inside one time as we know it. So the inside is going to be 4 times the inside even further, x squared plus 1 raised to the 3rd power. And then finally, the derivative of our innermost is 2x. Alright, so let's just simplify this all together. And we get y prime is equal to 24x times x squared plus 1 cubed secant cubed of x squared plus 1 to the 4th times tangent of x squared plus 1 to the 4th. And there we have it. Alright, and that is the end of our line for chain rule problems. We have done about 15 practice problems with the chain rule today. I hope that they have been very useful for you. We've done some pretty complicated problems, and I don't believe that you will have to do much more complicated problems that we've done here, but if you do see something longer, more difficult than this, you now have all the tools and practice that you need to chug through any problem thrown at you with a great sense of understanding of the chain rule and how to complete it. So hopefully you'll be able to finish it with time to spare. But I do hope that this has been useful, and let me know if you want to see more videos similar to this. And I hope you have a good rest of your day, and I'll see you in the next one.